Let's talk about some of the most foundational ideas in all of science and math. Because thousands of years ago, way before any calculators or computers, people were figuring out the universe just with their brains and some really simple tools. And what they discovered is, well, it's the groundwork for everything we have today.
It really is, and it's an amazing story about necessity. We're talking about the origins of, the calendar, the clock, the numbers you use in your homework. All of it was driven by these really practical needs, things like farming or building, or just knowing where your land started and stopped.
So where do we even begin? I think it has to be with the world's first real calculators in ancient Mesopotamia. And they made this choice that still affects us every single day. They picked a number system based on 60.
Yeah, base 60. It seems so random to us now, but that system is exactly why we have 60 minutes in an hour.
And 60 seconds in a minute. It's just everywhere.
It is, and they chose it because 60 is this wonderfully divisible number. You can split it evenly by 1, 2, 3, 4, 5, 6, 10, 12. Just so many numbers. It made it way easier to handle fractions when you're trading things like grain or livestock.
And they had to keep track of all that. The scribes there developed cuneiform, right? Pressing reeds into clay tablets.
Exactly. These weren't poems or stories. They were ledgers.
The first spreadsheets.
Pretty much. They were the original accountants. And this math was absolutely essential for managing their cities, for building projects. They could calculate the exact area of a field for taxes or the volume of a grain silo. Their whole society really depended on that mathematical precision.
It's amazing. So while Mesopotamia was laying the groundwork for calculation, their neighbors in Egypt were perfecting this really practical applied geometry.
Yes. The Egyptians used a different system, a decimal system, so based on the number 10, like we use. But the real driver for their math was the Nile River.
Because it flooded every year.
Every single year. Which was fantastic for the soil, but it was a total disaster for property lines. The floodwaters would just wash away all the markers.
So wait, every year they had to redraw all the maps.
Every single year. Government officials had to go out and recalculate the size of every farm all over again, and for that you need some serious arithmetic and geometry skills.
And think about their tools.
Yeah.
No laser levels, no tape measures.
Right. The engineers used these simple knotted ropes to create perfect right angles. That's how they built the pyramids with such precision. They were essentially solving complex geometric problems just to lay a single stone straight.
That is just incredible, using a rope to build one of the wonders of the world. And it wasn't just for building. They used fractions for really critical things, like splitting up food rations for thousands of workers. It was project management on a massive scale.
Okay, so let's move from the math on the ground to the math in the sky. Because the Babylonians, who came after the early Mesopotamians, they took that meticulous record-keeping and aimed it upwards.
They were watching the stars for hundreds of years, believing they influenced life on Earth.
And this wasn't just casual stargazing. They were recording the exact, precise movements of the moon and the planets. And over time, they spotted these tiny, regular patterns. That's how they learned to predict things, like when a lunar eclipse would happen.
And to organize all that information, that giant map of the sky, they needed a system.
They did. And this is another huge gift from Babylon. They're the ones who divided the circle into 360 degrees.
Which we still use. I mean, first the 60-minute hour, now the 360-degree circle. Why 360?
Well, just like 360 is super divisible. You can divide it by almost everything. It just makes the math, especially for astronomy and geometry, so much cleaner than if they'd picked, say, 100.
And their data was so good, so precise, that later on, Greek astronomers were still relying on those Babylonian records.
Exactly. That flow of information is so important. The Greeks learned from the Babylonians and Egyptians first, but when the Greek philosophers got this knowledge, they asked a totally new kind of question. Not just how it works, but why.
That's a huge shift, moving from just practical counting to abstract reasoning. Thinkers like Thales and Pythagoras, they started to believe that numbers weren't just a tool. They thought numbers were the basic building blocks of the entire universe.
And that new way of thinking led them to develop the idea of the formal proof. A proof means you show, step by step, how one statement logically leads to the next. It guarantees your conclusion is true. It turns math from a tool into a science.
Right, so it's not just about memorizing a formula. It's about understanding why the formula must be true. That logical deduction is still the absolute core of how we teach math today.
And geometry became the main way to train your mind to think that way. The person who really standardized all of this was Euclid.
Ah, Euclid's Elements, the book that basically organized all of math.
It did. It started with the simplest ideas, what a point is, what a line is, and logically built up to prove really complex theorems. That book was so good, so clear, it was used as the standard math textbook for over 2,000 years.
2,000 years. That's unbelievable. And you can see that logic in their buildings, like the Parthenon. Perfect, balanced, and stable.
And they didn't just measure buildings, they started measuring the world itself. This is where the math just gets mind-bending. There was a Greek scholar, Eratosthenes, who used geometry to estimate the circumference of the Earth.
Okay, this is one of my favorite stories. His method was so simple but so brilliant.
It was. He knew that on a certain day in a city in southern Egypt, the sun was directly overhead. If you looked down a deep well, you'd see no shadow. But at the exact same moment, in Alexandria, which was further north, a vertical stick did cast a shadow.
And that shadow, even a small one, proved the Earth had to be curved. Because if it were flat, there'd be no shadow in either place or the same shadow.
Precisely. So Eratosthenes measured the angle of that shadow. It's about 7 degrees. He knew the distance between the two cities, so he just did the math. 7 degrees is about 1/50th of a full 360-degree circle.
So he multiplied the distance by 50 and got the circumference of the entire planet with a well, a stick, and his brain. And his calculation was incredibly close to what our satellites tell us today.
It shows you that scientists knew the Earth was a sphere long, long before it became common knowledge. They were even using more advanced math, like trigonometry, to figure out the relative sizes of the Earth and the Moon just by watching eclipses.
It's just staggering. But for all of that, maybe the single most important mathematical invention for the modern world didn't come from the Mediterranean at all. It came from ancient India. And it was the idea of zero.
Zero as a placeholder. It's hard for us to imagine, but before zero, doing complex math was a total nightmare. Try doing multiplication with Roman numerals. It's clumsy, it's slow, and you couldn't easily tell the difference between, say, 42 and 402.
Zero solves that instantly. It's not just a symbol for nothing. It's a placeholder. It tells you where the other numbers are supposed to be. It's the whole idea of place value. And
Yeah.
once you have that, everything, especially multiplication, gets so much easier.
It's revolutionary. That 10-symbol system we use, 1 through 9 plus 0, is the foundation for everything. It spread to the Middle East, then to Europe. Without the Indian number system, modern computers, which are built entirely on place value logic, just couldn't exist.
And they were making progress everywhere else too, right? In algebra, in trigonometry.
Huge progress, calculating the length of the year with amazing precision, developing early versions of sine and cosine. It was a golden age for mathematics.
And as that knowledge moved west, it was preserved and expanded on by scholars in the Islamic world. Places like Baghdad became these incredible centers of learning.
They didn't just save the old Greek and Indian texts, they built on them. This is where a scholar named Al-Khwarizmi comes in. He wrote the book that introduced a systematic, step-by-step method for solving equations. We call it algebra.
And his name gives us another word we use constantly today.
That's right. The word algorithm is derived directly from his name, Al-Khwarizmi, the process that runs every app on your phone, every search you make. It's named for a 9th century Persian mathematician.
Wow. And they needed this math for very practical reasons, like navigation and for telling time for daily prayers.
Which is why they perfected instruments like the astrolabe. It was like a handheld mechanical computer. You could hold it up to the stars and figure out your latitude, the time, your direction. It was essential technology for trade and travel.
Since they didn't have computers, they had to invent all these clever devices.
We forget how ingenious they were. You had the abacus for fast calculations in the marketplace.
The ancient cash register.
Exactly. Or the gnomon, which is really just a stick that uses its shadow to track the sun. And complex water clocks to measure time, day and night. And to build and calibrate these tools, you needed a really deep understanding of math and physics.
So if you connect all these threads, astronomy, geometry, timekeeping, they all lead back to one of the biggest challenges of the ancient world, the calendar.
Absolutely. Getting the calendar right was a matter of survival. You needed it to know when to plant your crops.
But it's so complicated, right? You're trying to balance the solar year with the lunar cycle, and they don't line up neatly.
Not at all. It requires these complex adjustments called intercalation. That's basically the process of adding in an extra day or sometimes a whole extra month to keep the seasons from drifting. It's a huge mathematical puzzle that every ancient civilization had to solve.
When you look back at all of this, you really see how science is this massive collaborative effort across so many cultures and centuries. Every time you look at a clock, you're using a system from Mesopotamia.
Every time you work on a geometry proof, you're using the logic pioneered by the ancient Greeks. And every single time you type a number into a calculator or a computer, you are relying on that powerful, simple concept of zero from India.
Modern space agencies are still using the same basic principles of trigonometry that were figured out by people with ropes and sticks. It's just the curiosity of those ancient scholars paved the way for everything that followed.
And knowing this history helps you understand not just what the rules are, but why they matter. It shows you the genius behind the concepts you use every day, so keep asking why.
Good luck with your studies.